Okay guys, so I'm going to show you how to convert an NFA to a DFA. It's actually pretty simple. Let's get started. So here we see um, an NFA that I have made, trying to make it look a bit complicated. So the first thing to do is create a transition function or transition table delta, and that's pretty simple really. So for a 0, from A, you can see it goes to A as well as C, and for a 1 it goes to A itself. Likewise for the rest. Now the only thing we have to do to make a DFA is to make another transition table. Here we see the first row is exactly the same. So A and C, and then A. The only thing which we consider a little different is that this A C is actually considered as a different state now. So that's about it. Other than that, there's nothing different. So the first row is done. Now we look at the second row. The second row will be written based on the first row, and we see there's a new state AC, and for that we create the second row. Now to understand where AC goes, let's look at a union of all the places it will go. So A with a 0 goes to A and C with a 0 goes to B. So we have A, B, and C, which is for uh, an incoming alphabet of 0. Let's look at for 1. For A, it goes to A. For C, it goes to B and C. Again, we have the same outcome. And then we go, now we've done A and AC. We see we've come up with a new state, which is A, B, and C. So move this state to the next row, and for a DFA, let's look at what happens for a 0. For A, it can go to A and C. For B, it can go to A, and for C, it can go to B. So it's a union of A, B, and C. And the same for a 1. So this is about it. This is our transition table. And the only thing we need to understand is the final accept state is going to be similar to the past. So the one which was there in the past was B. So anything with the B would be the final or accept state. So in this case, ABC is the accept state. So I've created this small DFA, which hopefully will be the same as the NFA. So it is a DFA. For a 1, it goes to itself, and for a 0, it goes to AC, and for 0 and 1, then it goes to A, B, and C, and then on there onwards, it's a self loop. So as you can see here, it is a very simple topic and probably a 5-minute exercise to understand how this works. Now let's take another example. In this case, we have this NFA, and this is going to lead to some interesting situations. That's why we're doing this. So you see here, the first thing we did was our transition table, which we know very well how to do that. So then we move to how to make the DFA. So in the first case, A, B, C is fine, but DFA needs something here. That something will be a dead state, and let's call it phi here. So empty set here. Let's see how that works. Now we go to the next row. This is a new item, BC. So we put BC here. Now BC in this case, where does it go? B doesn't go anywhere, whereas C goes to BC itself. So for A, it goes here. For B, however, let's look at what happens. B doesn't go anywhere, but C goes to itself. So BC goes to C. Now the only item which is left is C. So the C is the third row. C is essentially the same as what was there in the NFA. Now we still have a new state, which is the dead state. Now once we go into the dead state, there's no output, so 0 and 1, or in this case A and B, will be going back to itself. So that's it. We have a DFA now, and we can draw it very easily as well. There are 4 states: A, B, C, C, and dead state. That's it.